All right, so now we're moving on to even harder examples. We're going to try to find the domain of this function that has two radicals involved. So in this case, we're looking at square root of x minus 3 plus the square root of x minus 5. All right, so how do we handle this? There's going to be a set of x values that I plug into this guy that might cause square roots of negatives, and they may be very different from the x values I plug into this that cause square roots of negatives. So what we're going to do is isolate this into two different problems and then combine them at the end. And we're going to use a number line to do this in this case because this is where things get a little bit more complicated and we need to keep our work organized. So what we're going to first do, find the domain of this, then we're going to find the domain of this, then we're going to plot the domains on a number line and see where they intersect. All right, so let's first look at this guy. I'll do this in different colors here. So we have square root of x minus 3. We want the x minus 3 on the inside to be non-negative, meaning we want x minus 3 to be greater than or equal to 0. Okay, so what x values make this true? Add 3 to both sides, and that's going to imply that x is going to be greater than or equal to 3. Okay, so this is the domain of this guy. All right, so we're good with that. Now we need to find the domain of this. So I'll use blue for that. So we have square root of x minus 5. We want x minus 5 to be greater than or equal to 0. So we have x minus 5 greater than or equal to 0. But what does that imply? That implies by adding 5 to both sides, x is greater than or equal to 5. So that's the domain of this guy. All right, so now let's plot this on a number line. We have two different domains for two different parts of this function. So what this gives us is a nice little number line. You can do this for any domain example, by the way. And it's also pretty. Professors like to see this. So 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, and so on and so forth. Okay. 0 should usually be in the center here. So let's look at the first domain. X can be greater than or equal to 3. So what I'm going to do is I'm going to draw a square bracket at 3 and then shade in everything greater than or equal to 3. So everything over here, because that's what X can be. Just shade it all in. And if you're an artsy person like me, you'd like to do more shading so you can procrastinate and not do the problem. Okay, so that's the domain of this. We just shaded in everything greater than or equal to 3. Now let's take a look at the domain of this guy. We're going to plot the domain of this guy by doing a similar shading thing. So we have x is greater than or equal to 5. So I put a square bracket at 5, and I shade onward. Okay? So now, looking at this, the domain of the entire thing is the set of all x values that work for both, okay? The orange designates where it works for this one. The blue designates where it works for this one. Where they overlap is where it works for both, all right? So for example, if I tried to plug in 4 into this guy, there's no blue here. Plug in 4, I get square root of minus 1. So I cannot plug in 4 or anything in this orange region. Only can plug in where they both intersect or overlap. Okay, so the domain is going to be the set of all things where these guys overlap. So domain of f is equal to 5 and onward, including 5, because I have a square bracket at 5. Okay, so it's where they overlap. In which case, we found the domain of this entire thing by first isolating the domain of this, finding the domain of this, plotting it, shading and making things pretty, and then writing the domain where the x values where they overlap. So in this case, we are done with this example, and we're going to move on to an even harder case in the next one.